All right, so yesterday we did some stuff on constructions. Any questions on that stuff? So you should be able to construct perpendicular bisectors of a triangle's side. You should be able to construct a bisector of a triangle's angle. You should be able to construct any of the three altitudes of a triangle and any of the three medians of a triangle. Okay? So today we're going to kind of switch gears a little bit, and we're going to start talking about similar polygons. Similar polygons. Okay, so two polygons are if they have the same shape but different sizes. Same shape. Okay, so like for example, you could have a small equilateral triangle and a large equilateral triangle. Right? They're the same shape, but definitely in different sizes. Okay? Or you could have a small or a large parallelogram, let's say, and then a smaller parallelogram. Now, it's not enough that they're just two parallelograms. Like, that's not enough to say that they're the same shape. Okay, so there's a couple facts that have to be true in order to say that they're similar. You can't just say they're both parallelograms, so they're similar. That's not the way that works. So there's two facts that have to be true in order for two figures to be similar. The first thing is that the angles all have to be congruent, the corresponding angles, okay? So corresponding angles of two similar figures have to be congruent. Corresponding angles of two similar figures must be congruent. Okay, so if I look at this picture up here, like this angle has to equal that angle, this angle has to equal that angle, and so on. This angle has to equal this angle, and this angle has to equal this angle. All the corresponding angles have to be the same. All right, the second thing that has to be true is the corresponding sides of two similar figures must be proportional. Proportional. So what does that mean? Proportional, if you think about what a proportion is, a proportion is just an equation in which one fraction equals another fraction, right? That's what a proportion is. Proportion is just like A over B equals C over D. That's a proportion. It's an equation where you have one fraction equal to another fraction. So one way you can think about proportionality when it comes to side lengths is the ratio of a pair of corresponding sides has to be the same, regardless of which pair of sides you're talking about. So the ratios of corresponding sides must always be the same. Okay, that's what it means for side lengths to be proportional. Let me give you an example of what I mean by that. Suppose you have two similar triangles. Okay, so suppose you have a triangle like this, and then a smaller triangle like this. So the first thing I'm going to do is I'm going to label the angles so that you know which angle goes with which angle, because it might not be situated the same way. Like, let's suppose this angle actually goes with this angle, and this angle goes with that one, and this bottom right angle goes with this bottom left angle. Okay, so they aren't situated the same way, right? One of them is like almost like a reflection of the other and also smaller. All right, so suppose we have these two figures, and I have side lengths 15, 12, and 18 on this triangle. Oh, whoops, I got it mixed up. That's cool. I meant to do the smaller one first, so let me just, sorry about that. Suppose this one is 20, 16, and 24, and the smaller one is actually 12, 15, 18, 12, 15, 18. I'll give you a second to copy that. Sorry, I messed up. Okay, if you look at the two things that have to be true in order for figures to be similar, the first thing is that the pairs of angles have to match up. That's definitely true here. You can tell by the markings, right? Angles definitely match up. We have three pairs of matching congruent angles. The second thing that has to be true is that the corresponding sides have to be proportional. So the first thing you need to figure out is which sides go together, which sides are the corresponding sides. Well, if you think about it, the sides that are between the congruent angles would have to be the proportional side. So this side would actually go with this side right here. Does that make sense? The 20 would have to go with the 15, and the 24 would go with the 18. Everybody see how I identified which sides go together? So to check for proportionality, what you do is you just make sure that when you take the ratio of any two corresponding sides, you get the same thing every time. So in other words, if I were to take 16 over 12 and simplify that fraction, both the top and the bottom are divisible by 4, I get 4/3 as a simplified fraction. Well, if I were to take 20 over 15, it also simplifies to 4/3. And if I were to take 24 over 18, it also simplifies to 4/3. So since these are all the same, the sides are proportional. That's how you check for similarity. You make sure that the angles match up, that the pairs of angles are all congruent, and you make sure that every pair of corresponding sides is proportional. That means they all, when you make a fraction out of them, they all simplify to be the same fraction. Does that make sense? Let's just talk about notation for a second. Suppose we have, let me label these triangles. Let me label this one A, B, C, And let me label this one D, E, F. Okay, the notation that you use to indicate that these two triangles are similar is you would say triangle ABC, and then the symbol for similar is just a single little wavy line in the middle. That little single wavy line means similar to. Triangle DEF. And just like when you have congruence statements, the order of the letters matters, right? So angle A goes with angle D. Angle B goes with angle E, and angle C goes with angle F. The order of the letters definitely matters, just like it does when you're talking about congruent triangles or congruent quadrilaterals or whatever. When you're talking about similar figures, the order matters just as well. Okay, so that little symbol right there means similar to. Okay, so what if they gave us two figures and they wanted us to answer the question, are they similar? So what if they said, are these, let's suppose we have rectangles. Are these rectangles similar? And they gave us a picture. So suppose we have a small rectangle and a bigger rectangle. And let's say the smaller rectangle has dimensions 20 by 36. And the larger one has dimensions 30 by 52. So there's two things you have to check when you're checking for similarity. The first thing you want to check for is, are the angles, are the corresponding angles congruent? They definitely are, right? In this case, they're all right angles. So yeah, they all match up. So the corresponding angles congruent, you'd say, yep, definitely true. The next thing you need to check for is corresponding sides proportional. So are the corresponding sides proportional? Well, we need to check that. The way you check that is you figure out which sides go together and you make a fraction out of them, right? So in this case, I know the 20 goes with the 30. The way I know that the 20 goes with the 30 is not by my picture, but because they're rectangles and those are the shorter sides of the rectangles, right? So don't be fooled by a picture that's drawn weirdly, okay? I know that the 20 goes with the 30 because the 20 is the shorter side of this rectangle, and the 30 is the shorter side of this rectangle. That's how I know they go together. They're corresponding. So the 20 goes with the 30. So if I make that fraction, I get 20 over 30. And I just want to know if that is equal to, or equivalent to, the 36 over 52. Those two go together, right? I want to know, does that equal 36 over 52? So really all I have to do is just simplify these two fractions and see if they're equal. If they are equal, then the answer is yes, these rectangles are similar. If they're not equal, the answer is no, because the sides aren't proportional. So this simplifies to be 2/3. That's super easy. So the question is, how does this simplify? Well, you can look for common factors. One thing I can do is just cut it in half, right? Cut both of these in half. This would be 18/26. Let's see if that's equal. So I can cut it in half again. 18 over 26 would be like 9/13. And I don't really think I can simplify that anymore. This is definitely not equal. 2/3 is not equal to 9/13. So the answer is nope, they are not similar. Absolutely not. Does that make sense? How about this one? What if I said you have two rhombuses? Two rhombuses. You guys know what a rhombus is? Yeah, like a diamond shape. So suppose I have two rhombuses, one of which is looking like this, and the other one which is situated this way. Okay, and let's suppose the larger one has dimensions 10, 10, 10, 10, and 70 degrees. And suppose this one is 8, 8, 8, 8, and 110. So, same two questions. Do the angles match up? Are they all corresponding pairs of angles congruent? And secondly, are the sides proportional? Okay, so angles first. Well, if this is 70 and this is 70, what do these two angles have to be?
110.
110. How do you know that?
Because that's what has to be added.
Yeah, that's what has to be added to 360. Or I could just think of like parallel lines. Like, same side interior angles when you have parallel lines have to be supplementary. So if that's 70, this has to be 110. If that's 70, this has to be 110. This has to be 70, this has to be 70. So yeah, the angles match up. Angles congruent. Angles congruent. Yep. The second question is, are the sides proportional? Sides proportional. Well, I have 4 pairs of sides here. If I set up a proportion with all 4 pairs of sides, I'm going to get 10 over 8 every time. 10 over 8, 10 over 8. So yeah, 10 over 8 definitely equals 10 over 8, which definitely equals 10 over 8, and that equals 10 over 8. So yep, the sides are definitely proportional. So the answer is yes, the rhombuses are similar. Okay? So that's the first skill you have to have, is answering the question whether or not two figures are similar. One thing I forgot to mention, the fraction, like in this case right here, I got 2 similar triangles and the ratio of the sides was always 4:3 or 4/3, right? I could have like taken the ratio of the smaller triangle to the larger triangle and gotten 3/4. That's okay, right? I would have gotten 3/4 every time, 3/4, 3/4, 3/4. I happened to do it large to small, and I got 4/3, 4/3, 4/3. But whatever. That ratio right there is called the similarity ratio of the two figures. This is called the similarity ratio. So sometimes they'll say, are the two figures similar? And if they are, what is the similarity ratio? And they would have to specify, like they would say, what is the similarity ratio of the large triangle to the small triangle? And you'd say 4/3. If they said, what's the similarity ratio of the small triangle to the large triangle? You'd say 3/4. So they'll tell you which way to make the fraction. Same thing goes for these rhombuses. They could say, find the similarity ratio of the large rhombus to the small rhombus, and you'd say 10/8. or 5/4. Or they might say, find the similarity ratio of small to large, and you'd say 4/5 or 8/10. Does that make sense? Okay, so that's the first thing. Answering the question, are the figures similar? The second question that you have to be able to answer is, if you know two figures are similar, how can you find missing sides? Okay, so that's the second thing. So for example, suppose they gave us a problem where they said, you have two similar triangles. Okay, so suppose we have a triangle like that, triangle like this. And suppose these angles match up. These angles, let's say they're both right angles, and these angles match up. Okay? And they gave us some lengths. Like they said, this triangle is actually a 6, 8, 10 triangle. And this triangle has a length of 5 on its hypotenuse, and we're trying to find the lengths of the other two sides. Okay? So if they're telling us that the triangles are similar, which they are, they're saying these are two similar triangles, and we know which side goes with which. In particular, the 5 has to go with the 10, and the 8 has to go with the x, and the 6 has to go with the y. Then to solve this problem, all you really have to do is figure out what the similarity ratio is. So to find the similarity ratio, you just figure out which sides do you know both the numbers of, the 10 and the 5, right? So in this case, the similarity ratio would be 10 over 5, or 2. So to find the missing sides, I just have to set the ratio equal to 2 in each case. So to find x, I would just set 8 over x equal to 2. So 2x equals 8, and x equals 4. To find the y, I'd set 6 over y equal to 2. Cross multiply, 2y equals 6, and y equals 3. So step 1 in a problem like this is to figure out the similarity ratio. Step 2 is to just set up a proportion to find the missing pieces. Okay, let's do another example. Suppose you have two quadrilaterals that aren't really anything special. They're not trapezoids or rhombuses or rectangles or anything like that. They're just random quadrilaterals. And let's say I told you which sides go together by indicating it with angle markings. And I told you directly that these are similar quadrilaterals. Okay, and we have some side lengths. This is 8, 10, 6, and x. And let's suppose this is 6, z, y, bless you, and 12. So first things first, how can I determine what the similarity ratio is between these two quadrilaterals? What can I do? What am I looking for?
The two sides that have both numbers.
Yeah, I'm looking for the two sides where I know all the information I need to know, which is the numbers, the lengths of the sides. So which two sides are those? 8 and 6, right? There's an 8 here and there's a 6 here. That's the only pair of corresponding sides that I know both the lengths of. So I can use that information to find the similarity ratio. Similarity ratio would be 8/6, or 4/3. So then to find the missing side lengths, I could just set up a proportion equal to 4/3 each time. So to find x, I could say x/12 equals 4/3. To find y, I could set up a proportion that says 6/y equals 4/3. To find z, I could set up a proportion that says 10/z equals 4/3. 3 different little equations I have to solve. Each of them can be solved by just cross multiplying, super easy. This one would be 3x equals 48, so x is 16. This one would be 4y equals 18, so y would be 18 divided by 4 is 9/2, or 4.5. Cross multiply here, I get 4z equals 30. So z would be 30/4, or 15/2, 7.5. And that's it. Those are the missing side lengths. Does that make sense? So that's the second type of problem. The first type of problem is, here are 2 figures. Are they similar or not? And if they are, what's the similarity ratio? So to check that, you check the angles to make sure they all match up. And then you check the side lengths to make sure they're proportional. If they are proportional, what that fraction, that ratio is equal, is the similarity ratio. Second type of question is, here's 2 similar figures, find the missing sides. So it's a 2-step problem then. You figure out what the similarity ratio is first by using available information, and then you set up a proportion to find the missing information. Does everybody understand? Okay, so the homework is 2 more sections of IXL, okay? The first section of IXL is just called Identify Similar Figures, which is the first type of problem. They're going to give you a picture, and they're going to ask you, are the figures similar? Just say yes or no, okay? So you got to check for that proportionality. And the second section of IXL is called Side Lengths and Angle Measures in Congruent Figures, or in Similar Figures. In that case, they're going to tell you that you have similar figures, and they're going to ask you a question about a missing side length or a missing angle. Now, the way you answer questions about missing angles is like, if I know that this angle is 60, and I'm trying to find the measure of angle A, what's the answer? It's 60, because they're similar figures. They have to have all the same matching angles. So those questions are really easy. There's no real work required. If you know the measure of the corresponding angle in a similar figure, then you know the measure of that angle in the other figure. Okay? So that's it. The homework is the 2 IXL sections. So if you look at the homework for the week, make sure you have 3 IXL sections in total, 1 from Tuesday and 2 from today, and then also the 3 sections of Delta Math. So it's kind of like 6 things to do for this week. I'll do Monday. All right? That's it. I'm going to stop recording.